All right, back for part two of the applications lesson. This is one of the ones where instead of like the last one where we had to come up with our own equation, it's given to us, the equation's given to us, and then we have to just answer some questions and interpret and all that other business. So the function blah, 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 blah models the concentration, milligrams per centimeters cubed, of a drug in the bloodstream after T minutes. So this is a bit of a biology, medical type one. Sketch the function. Well, that's got nothing to do with the ability to interpret this application, but certainly we can use our skills from earlier in the unit. So probably you've got a little bit of a recipe for how to graph these functions in your head. The first thing that I think of are the x and y intercepts. Remember the x-intercept, the y-intercept happens when x is 0. Not x and y, t and c, I suppose, if we want to get technical about it. When x 0, the c-intercept, when t is 0, c is 0, and probably we're going to get robbed out of our extra points there again with going through the origin, but let's find out. We got 0 equals 0.16 t over t squared plus t plus 2, and this makes us think about our vertical asymptotes, right? As long as this isn't equal to 0, we can cross multiply, and in fact, then we see the top is 0 only when t is equal to 0, and we don't have any extra t-intercepts. So that gives us that single point at the origin, and then that's it. The next thing I think about is the vertical asymptotes, and the vertical asymptotes occur when this thing is equal to 0. And this looks like it factors, but it doesn't factor, and so I'm going to use the formula. The formula with A equals 1, B equals 1, C equals 2, and something a little bit strange happens that we haven't seen too much. Negative b plus or minus the square root of b squared minus 4ac all over 2a, and I get negative 1 plus or minus the square root of negative 7 over 2. So what does this mean? This has no solutions. No real solutions. So what does that mean? Well, no real solutions means that this doesn't have any vertical asymptotes. It means the bottom's never 0. So this means there's no vertical asymptotes. We haven't really seen that much. But, oh well, no vertical asymptotes. That means we can skip having to check out behavior near the asymptotes, so that's kind of good. What's next? Horizontal asymptotes. Horizontal asymptote, since the bottom of the function has a higher degree than the top, then the vertical asymptote or horizontal asymptote is y, or c at t equals 0. So that means there's a, this isn't very helpful. I see a point there and a horizontal asymptote, so probably something weird's going to happen. It's going to get close to the horizontal asymptote. It's got to go through that point, but not much help after that. Notice. So how are we going to get an idea of what this graph looks like? Is we might try some points, right? Let's just try some points to so I know that it goes through 0, 0, but maybe I'll try 1. When t is 1, I get a concentration of, just clunk it into my calculator, t is 1, I get a concentration of about 0.04. And then I might try 2 just to see what's going on here. And what's funny there is I also get 1 there, and I don't know how high up to go here, so I'm going to leave it for now. I also get a concentration of 0.04. So this is kind of weird. Maybe here, I don't know, 0.04. At 1 is equal to that, and at 2 it's equal to that. And I also know that it's got a horizontal asymptote of y equals 0. So it's got to go through this point, this point, this point, and then do this. Well, I can almost picture what's going to happen now. I don't know how far up it's going to go, though, I guess. And then here. And in fact, if I were to keep going and get a couple more points, I can see that it's going to do the same sort of thing on this side. Even though, you know, I know that it's got to get close to the horizontal asymptote, and it makes sense that it's negative because this thing's never zero, it's always positive. When T is negative, so is the concentration going to be negative, right? And there's the graph. Okay. So it says, explain what the shape of the graph tells you about the drug concentration. Well, and we'll talk about this negative in a second here because there's actually a little bit of business to worry about. But here, when I'm going to zoom out just so we can see the graph as I'm writing. I hope you don't mind. Yeah, okay. That should be okay. Get this out of the way just so I can write. At T equals 0, notice that the concentration, this must have been when the drug was administered, because the concentration of the drug increases to some maximum that's probably between 1 and 1, or 1 and 2 rather. At T equals 0, C equals 0, no drug in the bloodstream. And what is T in hours or minutes? Then the concentration increases quickly until it reaches a maximum. We think it reaches a maximum somewhere between 1 and 2 minutes. Reaches a maximum between 1 and 2 minutes. Then decreases and approaches 0, but notice that it never gets complete, it never completely disappears. Approaches C equals 0, but never quite equals 0. So the consequence is, at least according to this model, there's always going to be a little bit of drug in the bloodstream, right? Which is you know, maybe it's just the math model, or maybe this is just something that, you know, it's like there's a drug residue that will always be with you, at least a little bit. Dandy. And that's the idea of T goes to infinity, C approaches 0, but never quite. What I want to talk about for just a second before we I set you free on the homework here or whatever is the negatives. Is this okay? Say, well, T can't be negative. Time can't be negative. Well, no, T could be negative. That's possible because we think about T equals 0 is when the drug was administered. So a negative T represents time before the drug was administered. So that's okay. But administered. Okay, I think that's how you spell it. If not, you can laugh at me later. So negative this idea of negative time before the drug is administered is okay. What's not okay is it gives me values where the concentration is negative. Can I have a negative concentration of a drug in my bloodstream? Negative concentration doesn't make sense. But for T less than 0, c is less than 0, which doesn't make sense. So, what's the moral of this little story in red here? Restrict the domain. To t has to be greater than or equal to 0. And this is in interval notation. I hope that makes sense. We can discuss this in class. If you're not understanding why what I'm talking about here, there are some homework. Look at there. 5 teeny little questions to do for homework. Probably you'll get a chance to start your review. And that's all I have to say about that.